Callie is cutting a tree that is 10 feet long for firewood. She wants each piece to be 5/6 of a foot long. How many pieces of firewood can she cut of length 5/6 of a foot from the 10-foot tree? So sometimes when we're working with application problems and we see a fraction involved, it can sometimes make it a little bit harder to understand which operation we should use. Because when we have fractions instead of whole numbers or integers, it's a little bit harder for us to picture how large or how small that fraction value is. So anytime you're reading an application problem, if there's a fraction in there, and if you think it's the fraction that's making it harder for you to understand, I always recommend change the fraction to a whole number that you're more comfortable with and figure out how to solve the problem if it were a whole number, and then go back and do the same thing, but just replace the whole number with the fraction. So let me explain what I mean. Let's say this was a more basic problem where Callie is cutting a tree that is 10 feet long for firewood, but let's suppose she wants each piece to be 2 feet long instead of 5/6 of a foot long. Well, if we had a 10-foot tree and we wanted to know how many pieces of firewood we could get that are 2 feet long, that would be a little bit easier for us to visualize in our minds. So let's say this black line segment represents the 10-foot tree, and we want to break this 10-foot tree up into equal pieces that are each 2 feet long. Well, I'm sure you can already figure out that there would be 5 pieces, but let's visualize what's happening here. Every 2 feet, we would cut another piece. And so then there would be 1, 2, 3, 4, 5 total pieces. So basically all we had to do was take the 10-foot tree and divide it by each piece, which was 2 feet long, and then we would figure out that we could have 5 pieces. So now we can see that this is a division problem. So all we have to do is take the length of the tree, which is 10 feet, and divide it by the length of the pieces that we want. So instead of doing 10 divided by 2, all we have to do now is do 10 divided by 5/6. So now we're going to go back and put the actual value, 5/6, back into the problem. So when we were doing 10 feet divided by 2 feet, we were basically just asking ourselves, how many copies of 2 feet are in 10 feet? Well, that's a division problem. So now we just have to ask ourselves, how many copies of 5/6 are in 10? So instead of 10 divided by 2, now we're going to do 10 divided by 5/6. So we're going to write 10 over 1 as a fraction. We change the division to multiplication because that's how you divide by a fraction. And then we take the reciprocal of the second fraction. So this becomes 10 over 1 times 6 over 5. Now when I multiply fractions, I multiply the numerators. So 10 times 6 will give me 60. And then I multiply the denominators. 1 times 5 gives me 5. Now I'm left with 60 over 5, and that simplifies to 12 over 1, or just 12. So now I know that I could make 12 pieces that were each 5/6 of a foot long. And if you think about it, it kind of makes sense that the answer is 12, because think about it, 5/6 of a foot, that's almost 1 foot, like almost 1 whole foot. So if we wanted, say we wanted to know how many pieces we could get that were just 1 foot long, well, that would be 10, obviously. Well, if they're just a little bit smaller than 1 foot, then we could get a little bit more than 10 pieces. So 12 pieces makes complete sense.